This video is going to be about nuclear structure. The nucleus of an atom is made up of nucleons. There's two kinds of nucleons, protons, which are positive, and neutrons, which have no charge. We represent nucleons using nuclide notation, where X in this notation is the chemical symbol for the element, like you'd find on the periodic table. A is the mass number, which is the sum of all the mass of the protons and neutrons, or nucleons. And Z is the atomic number, which is the number of protons I have. You'll notice that I haven't said anything about neutrons, so I'll say N is equal to the number of neutrons, but there's no N in nuclide notation. So if I wanted to find the number of nucleons, I could take the atomic mass number, which is the sum of all the nucleons, and subtract Z, which is the number of protons. And so I could find the number of neutrons because I know the neutrons plus the protons equals the atomic mass number. Just a reminder, I didn't write it down before, Z is the number of protons in our element. So let's look at a specific example for nuclide notation. So remember, a nuclide is a nucleus with a specific number of protons and neutrons. So for example, helium-4, or an alpha particle, looks like its nuclide notation looks like this. And from that notation, I can tell that there are 4 nucleons, because the mass number is 4. And I can see that the atomic number is 2, so I know that there are 2 protons. And 4 minus 2 gives me 2 neutrons. Okay, so there's 4 nucleons total, 2 protons and 2 neutrons in this helium nucleus. We can also use nuclide notation to notate particles that are not nuclei. The particles on the left and their symbol in nuclide notation on the right. So a proton has an atomic mass of 1 and has 1 proton, so it's 1,1p. A neutron has an atomic mass of 1, 0 protons, so it has 1, 0n. An electron has 0 nucleons and a charge of -1, so we write it like this. A positron, which you'll soon learn about, is like the opposite of an electron, so it has a positive charge, so +1e. A photon has no charge and no mass, so 0, 0, and then you use the Greek letter gamma to represent a photon. An alpha particle, which you'll learn about soon, has the same nucleus as a helium, so it's 4,2He. Or sometimes it's written 4,2 alpha. The last particle that we don't have written down yet are the neutrino and the antineutrino. These also don't have any mass or charge, so 0, 0. Write a Greek letter nu for the neutrino. And then the antineutrino is the same, except for we put a bar. So there'll be a bar over all antiparticles. All right, that's the end.